In this lesson, we're looking at integration using trigonometric identities. Later on in following lessons, we'll look at how we would also do this using a process called integration by parts. This is a much easier process, so you'll be able to appreciate these three approaches when we do go through integration by parts. So I'll start by explaining where they come from. Once you understand where they come from, it's pretty easy to apply this into scenarios. The idea is that we turn the integral into a simpler integral that we can complete using the general rules discussed in the previous lesson. We're looking at the following two identities. So we're starting looking at the Pythagorean identity, sine squared x plus cos squared x is equal to 1. And the cosine double angle formula, which is cos 2x is equal to cos squared x subtract sine squared x. So we're going to use these to create these three identities, and then we're going to use those identities to calculate some integrals. Okay, so the first one. What we're going to do is we're going to start with cos 2x is equal to cos squared x take sine squared x. So as we want to be left just with sine squared, we're going to say that cos squared x is equal to 1 take sine squared x. And so we're going to sub this in, and we can find that cos 2x is equal to 1 take sine squared x take sine squared x. And therefore we end up with cos 2x is equal to 1 take 2 sine squared x. Now when we rearrange this and we isolate for sine squared, we can say that 2 sine squared x is equal to 1 take cos 2x. So by adding 2 sine squared x and subtracting cos 2x, then when we divide by 2, we get sine squared x is equal to 1/2 of 1 take cos 2x. And there we have it. There's our first identity that we need to be able to apply. The second one, we'll take a very similar approach. We'll start with cos 2x is equal to cos squared x take sine squared x. We know that sine squared x is equal to 1 take cos squared x. And therefore we can say that cos 2x is equal to cos squared x, take away 1 take cos squared x, which leaves us with 2 cos squared x take 1. Now, if we isolate this 2 cos squared x, we have 2 cos squared x is equal to 1 plus cos 2x. And you can see where we're going here. Then we divide by 2, we end up with cos squared x is equal to 1/2 of 1 plus cos 2x. Okay, so there's our second one. Nice and simple. Now for our third one, we are going to look just at sine squared x plus cos squared x is equal to 1. Now, because we're looking for tan and we're looking for sec, the obvious option here is divide everything by cos squared x. Because remember, sec is 1 on cos squared. So what we've got is sine squared x over cos squared x. We have cos squared x divided by cos squared x. We have 1 over cos squared x. So sine on cos is tan. So we've got tan squared x plus 1 is equal to sec squared x. And it's exactly what we're looking for. So there is our 1, 2, 3 identities. That's where they come from. Now, you don't have to be able to prove this. What you need to be able to do is use these as part of a process to integrate. So I'll show you why we're doing this. Remember, the idea is that they should make a more difficult integral easier. So let's first of all consider the fact that sine squared x, and we've written this down, so sine squared x is 1/2 of 1 take cos 2x. So let's look at the integral of sine squared x dot dx. Now, we can't take a substitution approach, and I'll explain this a little bit later on. This would be a by parts. So an integration by parts, which is one of the most difficult integration processes. We can simplify this by using this rule. So what we're going to say is that the integral of sine squared x dot dx is the same as the integral of 1/2 1 take cos 2x dot dx. And the reason this is easier is because we can start by taking this 1/2 out. So we've got 1/2 integral of 1 take cos 2x dot dx. And really what we have is the sum of two very simple integrals. So we've got 1/2 and we've got the integral of 1. And then we've got the integral of cos 2x. So we have 1/2 multiplied by integral of 1 is just x. The integral of negative cos 2x is negative 1 on 2 sine 2x. Then we've got plus c. And so that means we've got 1/2 x take 1 on 4 sine 2x plus c. So that's how we will apply this first one, our first identity, into calculating an integral. Okay, you may also see it as 1/2 x and 1/4. Remember that sine 2x is just 2 sine x cos x. See, so you could see that it's 1/2 x take sine x cos x plus c. Okay, so one of those two, I'd probably stick with the first version, but both are pretty easy to apply. Okay, so the second one now, we're looking at the integral of cos squared x. Okay, so we're going to say the integral of cos squared x is the same as the integral of, if we go back up here, we can see that it's 1/2 1 plus cos 2x. So 1/2 1 plus cos 2x with respect to x. So it means we can treat it as 1/2 the integral of 1 plus cos 2x dot dx, or 1/2 the integral of 1 with respect to x and the integral of cos 2x with respect to x. So we've got 1/2 multiplied by x, and integral of cos 2x. Integral of cos 2x is 1 on 2 sine 2x plus c. So now we've got 1/2 x and 1/4 sine 2x plus c, or we've got 1/2, and that's an integral, that's nice and easy to find. You could also say that it's equal to 1/2 x plus 1/4, and sine 2x is 2 sine x cos x. So we've got 1/2 x plus sine x cos x plus c. Okay, so there's our first two. Now when we look at the third one, and we're looking at the integral of 1 plus tan squared x with respect to x, it can be applied in a pretty straightforward way. We're looking at the integral of sec squared x dot dx. Now, we're going to take a slightly different approach here, and we're going to go over here and we're going to look at the derivative of tan x. Okay, so if we're thinking about the derivative of tan x, that's the same as looking at the derivative of sine x over cos x. And we should be able to see here that this is a quotient rule, which is v du dx subtract u dv dx over v squared. And so if u is sine x and v is cos x, then we get du dx is the derivative of sine, which is cos x, and dv dx, which is the derivative of cos, which is negative sine x. And we track this down now to look at this derivative. We have v du dx, which is cos x by cos x, subtract u dv dx, which is sine x multiplied by negative sine x, and we're dividing by v squared, which is cos x all squared. So this becomes cos squared x plus sine squared x over cos squared x. Now this is just a Pythagorean identity, which means it's equal to 1. So we've got 1 over cos squared x, and therefore we end up with sec squared x. So we know that the derivative of tan x is equal to sec squared x. So therefore we know the integral of sec squared x with respect to x will be tan x plus c. So if we follow this back over here, it's very, very simple now. So by knowing this derivative, we know that the integral of sec squared x is just simply tan x plus c. Okay, so there it is. There are our 3 applications of those integrals. That's our first dot point done. Now really it's just being able to apply these in scenarios where it may not be as clear as these 3 examples. Okay, so that concludes this lesson. The next lesson will be a selection of examples applying these integrals.